Okay, so the next one says an instrumental volume element in spherical coordinates is dv equals r squared sine theta dr d theta d rho. By integrating this volume element over the proper limits, show that the volume of a sphere of radius r is 4/3 pi r cubed. Now, I've shown where the dv comes from before in previous videos, so I'm not going to do that again. But it might look a little different because sometimes math and physics textbooks, they'll use different variables for things like theta or phi or phi or what have you. In this case, theta, I drew that theta kind of ugly, is the angle going from the y-axis down. And phi is the angle that sweeps from z and goes around 360 degrees. And then r is just the distance from where it's at. So basically r tells you how far it is, how far away it is. Theta tells you how far away from the y-axis it is. Phi tells you how far away from the z-axis it is. And with that information, you can point at any point on that spherical coordinate. So that'll help us with our limits. That's the big thing. So we start with what they give us. And we need to integrate this. So this will just be v is equal to, this is a triple integral of r squared sine theta dr d theta d phi. So we need to work with our triple integrals here. Let's start with r squared dr. Well, the limits, it can go from 0, that would be nothing, to the distance r. So this is our first integral. And that one's pretty easy. That one makes sense. Then we need the integral of sine theta d theta. And then we're going to need the integral of d phi. But the question is, what are the limits? Well, theta can go from the y-axis, the positive y-axis, to the negative y-axis. And that's half a circle. So that's going to go from 0 to pi. Meanwhile, phi, it goes here, but it can sweep around 360 degrees. So that's going to be 0 to 2 pi. And then just using a power rule, this is 1/3 r cubed. This is negative cosine theta, evaluated from 0 to pi. And then this is just 2 pi. So the volume is 2 pi over 3 r cubed times negative cosine of pi minus negative, so plus cosine 0. This is, cosine of pi is -1, but it's negative cosine of pi, so this is just 1, plus cosine of 0 is 1, so 1 plus 1 is 2. So volume is 2 times this, which is going to be 4 pi thirds r cubed. So we're able to get the volume of our sphere by integrating and adding up all these small little chunks. So that's all there is to it. If you want to know where the dv comes from, like I said, I think I talked about it in a moment of inertia problem when a triple integral was necessary. Could have been Gauss's law too, I'm not entirely sure, but I think the big thing here is understanding the limits of integration and being able to integrate it. So hopefully that makes sense, and hopefully that helps people out a little bit.